time. So on this map, we focus again, earliest scientific revolution and the forethoughts to it in the Renaissance down in Italy. Then you move north into the Northern Renaissance, European Renaissance. And that, of course, led to the scientific revolution that we spoke about, I guess, the end of last week. And hopefully, if y'all tuned in on my YouTube channel, maybe some on my notes there as well. Either way, to click back through very quickly, give you a highlight. Scientific revolution, again, we find the formation of the scientific method, deductive reasoning, as it is going to be called, in a more modern sense, where there's a focus on evidence for proof of things, not just relying on faith as it is. So again, scientific long-term, scientific revolution, you have a little less reliance in the decades and centuries following the scientific revolution that has allowed for a more open-minded way of thinking about things in general, not just science, but also, as it will turn out, social sciences, government, the equality of man, finding the perfect government, all of these things that could be conceived of, scientifically speaking, because the scientific revolution had put into the zeitgeist, or the common way of thinking, this new method of observing not only the greater ideas, of the cosmos, but also the more earthly ideas of equality of man and, again, government. So, to catch back up, or to get us where we need to be, click through here very quickly. We spoke about religious science in the 1600s, 17th century. Less of, again, a rejection of church. Many of these scientific scholars, thinkers, still died thinking themselves, again, devout Christians. Touched on that plenty. We're actually going to talk about Spinoza here at the bottom today. Very interesting figure. All got kind of kicked off with, again, Copernicus and the revolutions of heavenly bodies that he published. I believe it was 1543. Changed the concept of the cosmos from the old Aristotelian way of thinking. Everything was contained within 10 crystal spheres. Everything from the moon, the sun, the stars, the heavens, etc., and Earth was at the dead center. Copernicus, not the first one to conceive of this, as we come to find later, but at least the first one to be able to prove it somewhat scientifically that, yes, we are a heliocentric, not a geocentric universe. We continued by actually we skipped Descartes, we'll cover him today. We continued with Galileo, Newton, each with their own individual contributions. Actually, that's a good point. That's where I meant to pick up today, is with Newton's synthesis, all right. So again, just to leave it here for a second on this, I will catch y'all up for about 2 more minutes on where we were, and then we'll transition to brand new notes today. All right, so Newton's synthesis, Isaac Newton, or Sir Isaac Newton as we know him now in history. Circa 1640, he discovered many things, most, heavy among them, most influential among them is the concept of gravity, etc. But he also, kind of synthesizes or blends all of the previous thinkers that had come before, Galileo, Copernicus, etc., Brahe, and all of their findings he, kind of congealed, forced together, synthesized, again, whichever way you prefer to think of it. And that is, again, one of the forefathers or, early influences on what is going to be the new scientific method, the new way of thinking about things, that you must have reason and logic, to back these things up. So, again, I think we ended last class with looking at where magic and alchemy still fell in the world of science, while we think of the scientific revolution as a time of ultimate, growth in this deductive reasoning and, inductive reasoning, where you have to observe and analyze and repeat. You still had a lot of these key thinkers believing in some of the, again, what we would consider magic now these days, or a branch of it at the very least, like alchemy or astrology, where the stars and the planets and where they are in the world influence effects on the world. And then, of course, you had the study of alchemy, where the base concept was you could turn any metal, the old idiom being lead to gold, but any metal into gold. I believe another branch of alchemy also studied trying to find the elixir of life. So two big things there that, of course, we now look at as on this side of the scientific revolution and go, yeah, maybe if you drink the right vitamins, you might extend your life. But, all in all, a different core understanding of things as they are on this side versus what still some of these great scientists were believing at the time. All right. And this is where we're going to pick up with more of today's notes. So, methods of science. Speaking of the scientific method, we have Francis Bacon. Again, I very briefly touched on him. Good morning. The last time that we were together for notes, I think I may have touched on him a little bit more fully in the recorded and YouTube version. However, to go ahead and give him his full due today, Francis Bacon, circa, alive from 1561 to 1626. So born, roughly 20 years after Copernicus published his, groundbreaking findings or new concept of the cosmos, so to speak. Francis Bacon was an Englishman who made the scientific method in gathering empirical data an official part of the scientific community. And I say that, official part. It was really, the practices that he instituted that became the standard, again, of what we think of as the scientific method of that, observation. You observe things, you have to collect evidence. His was, if you are studying stones, that you don't just go and gather 5 or 6 rocks, you gather thousands and thousands and observe the differences between them. And you go to very strict and stringent standards of exploring things. It's not just, okay, this is shaped like this stone, thus I can judge all stones based on these two. Francis Bacon would say, you have to collect thousands of samples potentially, or more, as many as possible. Sir, could I ask you to pull your mask up, please? All right, and from those observations, you observe patterns, things that repeat themselves, what we call algorithms today. Certain things lead to certain things, absolutely. So in those patterns, you start noticing things that are common, again, to continue the example, between those thousands of different stones that you gathered, okay? So you break them open and you observe that some have large crystals inside, some have small, and then you start realizing that those patterns mean certain things within those stones, within those rocks. From those patterns, you form a tentative hypothesis. Now, I had y'all turn in a, hypothesis for a paper, or as we call it, something else now. But the general statement is, in science, if something happens, or if then rather, if I do something, then this will happen. So if I find this of this type of rock, then it will be consistent through all. That's what you're striving for, finding the all part. From that tentative hypothesis, you would then form a theory. Again, if when, or if then. From that theory, you go back and you start observing smaller parts of those individual stones that might influence what your initial theory was. Okay? Getting a lengthy process, I know. That's why this arrow keeps feeding itself. From those new, smaller observations, maybe you test the heat resilience of those stones. You form new observations, you notice new patterns, you form a new hypothesis based on those observations, those new findings. You form a new theory, feeds back into the top. Now, again, perpetuating cycle, frequently math is going to be used, or new concepts created in math by many of these scholars of the time, or incorporating, again, types of math that were conceived of in the Middle East, several hundred years before, by the Muslim scholars that we briefly touched on. So anyway, with Francis Bacon, that would become the standard. Catch up if any of y'all are looking up here for a moment. All right, go back a few and pick up with Rene Descartes. All right. Speaking of those maths, those new types of math that were conceived of at this time, again, early 1600s, late 1500s, get a bunch of discoveries lumped together. Let's put one out of the way. You have another great thinker, another great scholar by the name of Rene Descartes. Will lead to the Cartesian dualism is going to be one of his great contributions. He's a studied scholar at the time, so he doesn't just donate that, but we'll get to it in just a moment. Sorry, ahead of myself. Among his many achievements, he proved a link between the expression of algebra, and geometry. So the study of geometry, the discovery of geometry had great effect. The study of angles, shapes, and their relation to forces at play on them. Well, he realized, or he formed the theory and then proved that those geometric phrases could be expressed in algebraic phrases, meaning you could transfer math knowledge of this type into math knowledge of this type. So I'm no mathematician. I don't pretend to be. Those of you that are more studied in math, geometry and algebra, you can relate the two in your own understanding in your own mind. All right, so this means that, again, as they phrase it better, material world could be understood through mathematics. Things are equitable between what you can formulate in theory on paper with mathematical precision and what that translates to in the real world. Again, general emphasis on the deductive reasoning from a new general law to a particular example. So again, the way we discuss that cycle feeding into itself and reducing your focus with each experiment, that is, again, the deductive reasoning cycle. Now, Cartesian dualism, or, the dualism meaning two things that Descartes believed all matter broke down to, or all things broke down to, was a physical and a spiritual component, or matter and mind. That is the Cartesian dualism. What is an object? What is the meaning of something beyond matter and mind? And in that, and again, this gets into philosophy and math both, not history. So for the sake of just kind of getting us through this course and seeing his play into the Enlightenment, his mindset boils down to all things that are experienced can be explained. So through either matter or mind, you can explain all things, both physical and mental. Okay, so with this Cartesian dualism, we see really for the first time someone debating on, the reality, as I guess you could air quote it now, of things. What is everything? What is the meaning behind it? All of a sudden it's this deep thinking class, right? So between Bacon, Descartes, many others, but between those two especially, both were just great thinkers. They're scholars who expanded what we would call now the human understanding of self, as well as the world around us. That being said, both held very extreme points of view. So while they would both influence, and their findings would both influence the Enlightenment to come, and were grown out of the scientific revolution before, again, many of their views, when applied to society, would result in very extreme circumstances. It doesn't observe any gray zone in between, right? So I'm going to leave off with Descartes on that note as well. I'm also going to take a moment, pause this.